Hello and welcome to SETI Live. I'm your host, Beth Johnson, Communications Specialist here at the SETI Institute. Thank you to our viewers from around the world for joining us. Please let us know where you are watching from. And welcome to listeners on the podcast version of SETI Live, available on most podcast platforms. Today, I'm excited to be joined by Dr. Ariel Graykowski, who is the Cometary Lead for our Unistellar SETI Institute Citizen Science, Community Science project. Thank you for being here today. You have some fun stuff to talk about.
Yes, I do.
So if you haven't been living under a rock, you probably know that we're hoping that Comet A3 becomes this amazing, bright, visible with the naked eye comet. That's not the only one we're going to talk about today. We'll get to that later. But first off, with regards to Comet A3, are we looking at a comet of the century?
That's a really good question. I've been seeing that go around a lot online. Comet of the Century, C 2023 A3. Comet of the Century might be pushing it a little bit, I would say. In the last 100 years, we had a couple comparable and brighter comets than A3 is predicted to be, like Comet Ikea-Seki, which was a great comet in 1965. And that got as bright as nearly the full moon. So that's the comet of the century, really. And then also somewhat recently in 2006, we had Comet McNaught, which is a very comparable comet to A3 in how bright it got versus how bright we are expecting A3 to get. And even some of the physical properties too, like forward scattering, which we'll talk about later as well. So maybe not comet of the century, but comet of the decade, perhaps, is what I would call it. But even so, like you said, another comet has appeared recently that might just take that title from it all of a sudden.
Oh wow! I have to say, like, when it comes to this whole comet of the century or comet of the decade kind of designation, we have definitely had our fair share of disappointments in the past 20 years or so. Things that have looked like they'll be amazing, and then they get towards the sun and they don't come out the other side, really.
Yeah, definitely.
So when it comes to Comet A3, what predictions have been made about this comet?
Yeah, so for Comet A3, I think this potential disappointment has really rung true for a lot of comet enthusiasts. It was discovered in January of 2023. So the hype has been building for over a year now. With around then is when it was predicted to be a naked eye level comet now. And so we were just waiting for it, monitoring it, hoping it would pan out and match observations. And so as people have been monitoring it, many different kinds of predictions have been made. You've seen ranges of how bright it could be of several magnitude differences. And so really pinpointing what that final peak brightness is going to be has varied quite a lot amongst the community. And there are some reasons for that. There's this prediction of how much forward scattering is going to help the comet look brighter, because when a comet is in between the Earth and the sun can reflect on the dust really strange, and make it appear brighter than it is. And that seems to be the case for Comet A3, and exactly how much that's going to happen has been highly debated. And there's also just how it's going to look. People like to predict how long the tail is going to be, and when that's going to happen. And also if it's going to break apart. So this comet's getting pretty close to the sun. It's not a sun-grazing comet like we're going to hear about later, but it is getting close to the sun. And so it's going to be really affected by heat. And that can cause the comet to fragment sometimes and break apart. And so in some cases, some of these comets that we got really hyped about in the past, basically they started fragmenting earlier than we hope. And it just got fainter instead of brighter as it lost its mass. And so that's been a big fear around A3 too. So we wanted to know if it's going to do that or not. And it just passed perihelion on the 27th. And so we have some insight on these things now.
So perihelion is when we're talking about that closest point in its orbit to the sun.
Yes, exactly.
Okay. I'm gonna come back to you on this. I just want to welcome in some people. Let's see. We have people watching from Arizona, here in California, Idaho, Ohio, Quebec. Bonjour. Cambodia. Wow, welcome in. Some more from California, from Mexico. So getting to be a very global audience today. Thank you so much. So one of the ways that we're observing this comet, of course, is using our community science network between Unistellar and the SETI Institute. So what has the Unistellar Community Science Network observed for Comet A3?
Yeah, so we started observing Comet A3 back in 2023. And really more so early 2024 is when we really started ramping that up. But late 2023, we started. And this is some of the plots here, some of the data. And so you can see this blob of data from late 2023 to early 2024 that we have there. And that's when we really started observing. But we thought, maybe we have some good data from when it was fainter. There was a while we didn't think our unistellar EV scopes could see that faint, but we went back into the archives and we saw that we can, and we did see A3. So we're able to also plot some of these fainter data points earlier on, which was really helpful in creating some predictions, right? So that's why you see those two blobs of data points on here. And this is basically how bright the comet is over time. And what we can do with this is fit different predictions to it, different models, to guess how bright it's going to be at the peak. And that peak is in that middle there, where you can see these two vertical dotted lines, one representing the perihelion and one representing the close approach to Earth, which happened pretty close together there. But you can also see I have a lot of different squiggly lines fitted to this data. And that is because of all these different aspects that this comet has, undergone and that we've been considering. How do we fit this properly? So, for example, if you look at just the white dotted line, that is when I fitted to the data in that first blob and in that second blob up to that point where you see the data starts to dip off.
Yeah.
That was a really interesting moment for astronomers. There was a few theories that came out around that. So people kind of started panicking a little bit when we first started noticing that the comet's getting fainter, even though it's getting closer to the sun. That's strange. It should be getting brighter. It should be sublimating more as it gets hotter. And the more sublimation, the more dust and gas is in the coma and the tail, the brighter it should reflect. Mm-hmm. So what was happening there? There's some ideas around that. One is this phase angle idea. And that's basically where at really low phase angle, and the phase angle is the angle between, it's the sun, the observer, and the comet. Is that right? No. It's the sun, the comet, the observer. I always have to think about it. I always get that backwards.
So the sun, the comet, and me, basically.
Yes, exactly.
Okay.
So when that phase angle is low, that means you're kind of, everything's in a line. And it's basically, when you're looking at the comet, it'd be like looking at the full moon. So it's fully lit face on from the sun, essentially. And so at this low phase angle, because it's fully lit and there's no, it's not shining at the side of it, it's not producing shadows. And so with these surfaces, these small bodies, we see this a lot, you get something called an opposition surge, where because those shadows suddenly disappear, you get a sudden brightening. So we think that this little peak here is actually due to an opposition surge caused by the phase angle. And then the phase angle started increasing again, and it started acting more normal. And then as it went on too, there was a moment in time where because of the geometry, the Earth was actually getting farther away from the comet, just a bit for a little while. And that kind of added to this continued dip. And if you're farther away, it looks fainter. If you're closer, it looks brighter. You can just kind of intuitively get an idea of that. So we get this sort of long dip here. And then we start to see a rise again thank goodness. But so what I decided to do here is a couple different things. I was like, okay, let's just fit to all of the data, not just the data before the dip. And that's what is in red. And so the red curve doesn't fit the data at all. The white curve only fits part of the data. It's probably some mix. So those two peaks, one of them puts it around 0, the other one puts it around like 3 magnitude or so, which is, fainter than we wanted. We wanted it to be closer to 0. The reality is it's probably somewhere in between there. There should be some sort of a mixing between these two fits. But then there's a third fit too. And that's that orange data that has this weird spike. And that spike, if we were to zoom in, it fits really well where the opposition surge peaked. And so what I did here for this orange fit is include a term for the phase angle. And so it doesn't fit perfectly either, but it does fit there. And in reality, we can't really trust this fit fully because I really should only be adding anything about the phase angle when I'm looking at those small phase angles, but not the rest of the time. So the fit here isn't perfect, but it does show that this probably did have a lot to do with the phase angle, and that's why we're seeing that spike there. And then just to further emphasize the phase angle thing, the blue is just the phase angle plotted over time. So you could see when it's at the minimum, that's when you saw the little peak in our data. So yeah, these were interesting things. Not only the phase angle, it seems to work well, it doesn't seem to work perfectly. And so some people started thinking maybe this dip is also being contributed to because the comet's already breaking apart. And so this is what made people sad. If the comet's already breaking apart, then maybe it will fizzle out before it even gets here. And so it was highly debated.
Yeah. And where are we at today? Because I know this data kind of is backwards in time a bit. Where are we at? And kind of explain a little bit about what you mean when you say magnitude and what that number kind of refers to, because that's always confusing to people who aren't spending their time staring at telescopes.
Yes. Yeah. Magnitudes are, first of all, they're backwards. So lower numbers means brighter, and it's a log scale too. So basically when you go up a magnitude, it goes up by more than just 1, right? So each magnitude is significantly brighter than the last. And so now we're at this white vertical line here. It looks kind of messy. Oh, I'm like using my mouse as if you can see. We're at the center. We're at perihelion. And the reason we don't have data here is because it's been really hard to observe. There was a period of time where the comet was crossing the sun, so we weren't able to see it in the nighttime sky. And now it's been in a really early morning object, kind of rising along with the twilight, this pre-dawn sky. And there's been some amazing pictures, which we'll show some of them later, but it's really hard to catch it on time before it gets saturated. It's really bright, so it gets saturated. Also, the twilight of the sky starts to mess up the measurements too. But it looks like we could show maybe the next slide. In this light curve, this is from a database called COBS. So people submit their own measurements to this database. So this curve on the bottom right there, that is a similar curve to what I was showing. And so some people have made estimates of where it's at now. And it seems to be following the light curves pretty well. It seems to be like reaching up to about 2 to 0 magnitude. I think I've seen about 1 lately. And this is the part where I wanted to talk about forward scattering as well a little bit. We're seeing that it's actually brighter than the simple prediction. So forward scattering is at play, like some people have predicted. And we're able to see how much brighter it gets, kind of tells us how dusty the comet is versus how much gas it has. So as we watch it get brighter than predicted, we can make those estimates.
So I'm I'm learning so much. Like I know comets, I know what they are, I know how they work, but this is getting into very much the nitty-gritty of observing comets, and it is far more complex than I realized. One of the things that I'm kind of excited about, like you were saying that this has been visible in the early morning skies, but that's going to be changing, correct? We're going to see a shift in the timing of when we can see it. And I'm kind of excited about that because I'm not a morning person, as everybody at the Institute knows. So what can we hope for in the viewing of this? How can people go look at it?
Yeah. So right now it's getting difficult again, even more difficult than it already has been the last few days.
Mm-hmm.
It's crossing the sun again. And so around mid-October, it's going to become a nighttime object. Thank goodness. And starting like October 9th or so, you could probably go outside and try to catch it. And it should get higher and higher in the sky every night through October. And so this October 12th is when the comet reaches its close approach to Earth.
Mm-hmm.
And so it should still be really bright, should still be naked eye. You shouldn't have to get up early or stay up late to see it. So that it'll definitely be a good time to see. And I'm excited for that too, to get more data more easily, basically.
So speaking of that, let me like welcome in. There's a few more countries that I want to acknowledge here. We have people watching from Greece, from Germany, Willkommen, from Italia, Italy. I'm a polyglot, so sometimes I forget that I'm reading a foreign language. So welcome in. Yeah, we're covering, now we're just covering Europe over there. So we've got several different continents working. Okay, how do we observe this comet? Where do we look in the sky?
So it's going to be in the southwest horizon, starting like I said, October 9th might be a little early, but it's starting around then. Go out every day, look in the southwest sky. It'll start in Serpens, the constellation, and move through Ophiuchus.
Ophiuchus.
Thank you. It's the first time I said that word out loud. I realize I've only ever said it in my head.
So I'm gonna admit to something. The only reason I can is because when I was doing undergraduate astronomy, we had to pick a constellation, and I picked that one. So yes, I had to give a talk about it. I understand. Go ahead.
But yeah, so it'll rise through those constellations, getting higher in the sky every night. That makes it easier to look up and see, to point a telescope to and see. It will also start getting fainter, though. However, it should still be naked eye through October. So you should definitely go out and just take a look, even if you have no tools.
All right. So how do people get involved in the community science aspects of this? Do they need a unistellar telescope? How do they contribute their data?
Yeah. So for our work specifically, the project that I do, and the light curve that I showed earlier, those are all from unistellar telescopes. So if you own a unistellar telescope, you can check what missions we're doing. And usually there's a few comet missions at any given time. And we monitor them for a long time. I like to try to get a full light curve if we can. And so you can see what to look at. It's really easy. Just can click on something to take your telescope right to where you need to look, and then upload your data, and then I could do science with it. Right. But it's not the only way. We collaborate with other citizen science groups too, like the AFA in France. And so we've worked with them. They've contributed data to me to do a project on another comet. And also I showed the COBS database, which anyone can contribute to if you have your own device, own telescope, and you know how to make measurements. You can submit your measurements there too. So if you want to get involved in comet science, there's a lot of ways. And if you want to get involved in the unistellar project, it's very easy, but you do need a unistellar telescope.
Okay. So there are ways outside of unistellar, but to contribute to this specific thing, this is from unistellar. So you will need one of their many amazing telescopes. And I say that not as someone who's making any money off of it, I promise. You have a really cool video of simulation. Should we show that to the audience here? Because
yeah,
can you give us an intro to the video? I feel like now I'm on a real talk show. So what is this video about?
Yeah, the video is cool. Somebody made a prediction of how the morphology is going to look. When I say morphology, I just literally mean how it looks, the shape of it and stuff. We wanted to know how long the tail is going to be and what direction the tail is going to be at certain times. So this starts like late September, right before perihelion. And you can see how close it was to the sun. And then it's going to cross the sun, and this will be October. And so we can expect this really long tail. We're seeing a long tail now, and then we won't be able to see it when it's in front of the sun. And then we should still see a long tail then too. But it gives astronomers a good idea of, when I look in the sky, what is this comet going to look like tonight? He's able to make this simulation because we know about the dynamics of the gas and the dust in comet tails and how they're affected by the velocity of the comet, the orbit that it's on, and also the sun. The sun plays a role, especially in that ion tail that always points away from the sun. And the dust is affected a bit by the sun too, but also by the velocity. So he's able to put that physics into the simulation so we can see what to expect. So I just think it's a cool simulation and handy if you're looking for it in the sky. What should it have a long tail right now? Is it sweeping in a weird way? It helps you find it.
I do like that it shows both of the tails. Like sometimes I think that always deserves a bit of an explanation. So comets generally have two tails that we can see, and one of them is that tail of gas and dust.
Yeah,
that's sublimating out from the comet itself, and the other tail is the ion tail. Can you explain the ion tail for our audience?
Yeah, the ion tail, basically much smaller particles, these ions, than the gas and the dust in the dust tail. Because they're so small, they're much more affected by the solar radiation. And so that solar radiation coming from the sun is going to push those and have a greater effect than any ejection velocity it had before, or anything. And so usually you'll see it. You can imagine seeing pictures of a comet with two tails where there's a blue ion tail in a different direction. And that direction kind of tells you where the sun is if you go the other way. Whereas the dust is bigger. And so it has this ejection velocity and it's on this orbital path. And it has a little more force because of that, combating with the force of the solar radiation, which has less of an effect, but still will push it a bit.
So I just want to, you also included in your slides some pictures that people have taken, and I think these are valuable to look at. What are we looking at here? We have just a wide variety from the last basically week or so.
Yeah. I just picked some pictures that people have been posting online and through our Unistellar network over the past week or so during perihelion. And some of it, like the pink one on the top left, I really like. I think it's cute, but also it really exemplifies how challenging this was. This was taken by one of our citizen astronomers in the Unistellar network, Ryuichi, who was trying to take a picture and really struggling with the twilight. This was a live view of what his telescope was seeing. And you can see there's a little bit cloudy. The twilight is making things look pink. The comet is there. You can kind of see it, but it's cool you can see it at all. That means it's bright, even though the twilight's affecting what he's seeing.
Right.
And then right below that, I have a picture that he did take of it that was successful from his unistellar telescope. And he had to turn the gain way down. He had to shorten the exposure time and take a quick picture so it wouldn't saturate the telescope. And that's what we were able to get. So I thought that was really cool that he was able to capture this. It's been a challenging object for us. We haven't tried to look at a bright comet during twilight before. So I've been really grateful to Ryuichi as we've been going back and forth discussing what settings the telescope should be at and him trying to get it. So that's been fun. But then I also just grabbed some other pictures. The top middle one was supposed to be a GIF showing the sunrise with the comet, to show just how quickly the sun rises as soon as you're able to see the comet, twilight comes. And then the lower one too, even with clouds and with the sun rising, you can see a really long, beautiful tail. It's a very stunning picture. And even though as astronomers, we hate clouds, I think it's just really cool to see this comet through all of this. And it's pretty as well, of course. And then, of course, we have this picture on the right taken with a telescope and a camera, of course, showing just the beautiful structure of the dust tail and the ion tail. That ion tail, which is kind of flapping in the solar wind, as somebody said in our citizen science network, which I thought was funny. But it's being really affected by the dynamics of that solar wind. And as it gets kind of shot out initially straight, if you could kind of tell that towards the nucleus, and then just kind of flaps around as it goes on. But yeah, I thought these were really excellent pictures. There's so many online if you search, especially this group, or I keep using my mouse, especially the group on the right. They've been putting out color versions of this picture, and they're really stunning. Definitely worth taking a look at some of their pictures.
And to kind of let people know, if you do have a unistellar telescope, we are running a comet photograph contest for this particular comet. So please check our Instagram and Facebook, our page, Unistellar's page, the Unistellar group, and take a look at the rules for that and share your pictures. There's some really cool prizes involved. So this is not just a contribute to the data. This is a what can you get a good picture of, and show us those. I want to welcome in some people from Pakistan, Nova Scotia, welcome in, South Carolina, and Texas, and Tennessee. So wow, okay, so more people, thank you so much. Also, Julia, thank you for the stars on Facebook. Always deeply appreciated. So, all right, fantastic comet. Looks great. Possibly could be pretty amazing. I'm going to take a few questions from the audience, and then I'm going to ask you about the other thing.
Yeah.
So, aristocratic philosopher is asking, is the comet dangerous? Is this a potentially hazardous object for Earth?
It is not. It is not getting nearly close enough to the Earth to be even classified as like a near Earth object. So not dangerous at all. We're safe.
So there you go. This is not Night of the Comet, everybody. You're all okay. And for those of you who didn't get that reference, it's fine. I'm old. It was a deep cut. Don't worry. Broken Symmetry is asking, what would solar observers see when trying to look at this comet?
Solar observers, like how close it gets to the sun?
I would guess, like, it's coming in at twilight and dusk and dawn. So if you're trying to observe the sun and the comet, is that can you do that?
Oh,
can you see it?
I would say, okay, so when the sun rises, it's not been bright. I haven't seen a picture of the sun and the comet together. I don't think it's bright enough for that, especially the tail. If anything, maybe the nucleus, or like the nucleus and the coma, but I haven't seen a successful picture like that. I think trying to take a picture of them together won't happen. I don't think it's that bright. Yeah.
Fair enough. Carl Welch is asking, we talked about where to see it at night, but before then, up until next week, where do we look in the morning sky?
So that's a good question. Right now, actually, I think it is like doing its sun crossing thing. So I think right now, maybe you could still catch it if you are like wake up early, right with twilight. But I think at this point, we have to just wait for mid-October.
We'll have to wait for when it gets done with that. Okay. Yeah. All right. So this is possibly the comet of the decade. Maybe not, because we have something else coming here. We just literally found this week is Comet 2024 S1 Atlas. So tell us about this comet and what we might be able to expect from this one.
Yeah. So this has been exciting and also kind of like silly, I guess. I talked about how long we've been hyping up Comet A3 and how long we've been debating about what it's going to do and figuring out why it's going to do what it might do. And then all of a sudden this comet is discovered just less than a week ago and might be brighter than A3 in a month. So this is a sun-grazing comet. It's in the Crux family. And basically, the Crux family is this family of sun-grazing comets that all originated likely from one parent body that existed a long time ago and fragmented. And now, every now and again, we get little fragments of it and we catch them. And usually, these little sun-grazing comets are little, and they don't get bright enough to see until they're very close to the sun, very close to perihelion, closer than this one usually. And then they burn up and disintegrate, and they don't survive perihelion at all. So this one we caught actually pretty early for a sun-grazing comet as far as they go, over a month before perihelion. And it's hard to say how big this one is. We're hoping it must be bigger than the typical sun-grazing comet, which is like a few tens of meters. Maybe this is a few hundreds of meters. Wow. Because we are able to catch it early and it's already as bright as it is. This comet may get as bright as -7, which is a similar brightness, maybe even brighter than Venus in the sky.
Wow.
So that will definitely give Comet A3 a run for its money this month. The problem with it, as I said, is that it's a sun grazer and they almost never survive perihelion. The last one that survived perihelion was Comet Lovejoy. And that comet was really, really beautiful. And so we're kind of hoping for something like that. It did only survive for a few days after perihelion. So we got to just really keep an eye on it, and hopefully we see something beautiful. But we'll see. It could disintegrate before that as well. Yeah.
Will you be adding this to the Unistellar observations? Are you going to run another campaign on this one?
Yes, actually, we just added it to the website. It just got its name, I think, a couple days ago. Mm-hmm. It had a different designation before, so it just got its official name, and its ephemeris seems pretty locked in. Like, we know its orbit pretty well now, so we're able to put the ephemeris online. People can look it up and point their telescopes to it. So we did that, and we definitely want to watch this. It's going to be a fun battle between these two naked eye objects, potentially naked eye for this one, but
I'm here for it. I'm still looking for. I remember Comet Hale-Bopp, and so I want that comet where you just like go outside, look up comet. So I'm here for it. Dueling comets, I'm all for. Yeah. I'm gonna ask this one last audience question because I think it's an important thing to ask. How do we calculate a comet's apparent magnitude? Do we use just the coma? Do we integrate the whole tail? Where does that come from?
We try to just use the coma, the nucleus and the coma. We don't try to integrate the whole tail. And so we talk about the whole magnitude. We talk about the nucleus and the coma. And yeah, the apparent magnitude is basically what we're seeing versus an absolute magnitude, which is what we would see if we put the comet at a standard distance from Earth, essentially. So that's what we mean when we say apparent. It's just what we see.
Yeah, I know that's been a bit confusing when it comes to the mini moon. Some of the things are referencing absolute magnitude when they mean apparent magnitude. So it is an interesting dilemma, and sometimes very confusing to people who are not, like I said, not staring at their telescope all the time. So
yeah, and even still, it's confusing.
All right. Well, what's next for you, Ariel? Are you doing anything exciting, or are we just hoping for comets at this point?
Always hoping for comets. I mean, these two are the main focus right now. There might be another potentially naked eye next year, so we'll hope for that one too. But we're going to keep monitoring these as they come. I do want to point out for this new Comet C 2024 S1, it will be visible in both hemispheres too. I just saw a question about that, so I wanted to answer that really quick. It'll be easiest for Southern Hemisphere the days leading up to perihelion, and easiest for Northern Hemisphere the days following. So Northern Hemisphere, let's hope it survives. But yeah, I'm just going to keep monitoring these. We're going to try to understand what's going on, see if we can attribute any of the features that we see to any of the physical attributes that I mentioned before, forward scattering. What does that mean about it physically? Dust, gas, how much, how big, all those things. That's why we monitor for so long.
Well, I'm excited to see how these two comets turn out. I'm definitely looking forward to being able to go out at night and look at them again. Sure. I was not enthused about the whole early morning twilight thing, but
Fair.
I will. I'm a night person. I will be willing to stay up and check for this, and plus it'll be a bit higher in the sky, so that will be nice as well. Yeah. All right, Ariel, thank you for joining me today. Always appreciate it. Always wonderful to see you. I really hope that we get some good images out of this and some great data. And of course, once again, I remind everybody that if you do have a unistellar telescope, we are running a contest for pictures of Comet A3. So check out our Facebook and Instagram posts about that contest and submit your images. I'm looking forward. Hopefully we'll have you back to talk more about one of these comets and give a nice shout out to whoever managed to get some really good pictures of it. Thank you again for joining me. Thank you everybody for being here today. I want to remind you that the SETI Institute is a nonprofit. We are 501c3. So if you are interested in helping support us, your bits, your stars, your subs, your super chats, those all help our outreach program. And so, feel free to hop over to the website. You can click the big red Donate Now button and support our outreach program and the citizen science program, all of that. So thank you so much for being here, for watching. Give us a like, a share, subscribe, all of the things. And we will see you next week. I'm still in the process of scheduling it, but we will definitely have something really cool going on. So take care, everybody, and have a fabulous rest of the week.
Bye-bye.